All right, welcome back to our next video. So in this video now, we're going to be going over something called polynomials and how we do operations with them. So we've already dealt with things like monomials, and I think we've done some polynomials for the most part. A polynomial is different from a monomial, okay, in one key aspect. So a monomial is if I have a single a single entity with a coefficient and a variable and exponent. So for example, this is a monomial. It's just by itself 5x, right? There's a coefficient on it, there's a variable with it, and there's a power technically to it. So in that regard, we have actually gone over how to do monomials for the most part. So let's now go over how to do polynomials, which we've also done, because a polynomial is very similar. For example, a polynomial could be if I had like 5x plus 1, because now I'm actually combining multiple terms. This is a monomial, and this is a monomial if you think about it. So technically, this is a polynomial right here. So we've dealt with polynomials already, but now we're going to be doing some operations with them. And it's going to get a bit more complex because now we're going to be having things like powers. So as you can see here, I have to the second power to the third power, and we're doing different operations like that. So we have to really know our exponent rules. If you have not done that yet, you can wait for my next video coming out on exponent rules. If not, you should have hopefully reviewed that in pre-algebra already, but I'm going to make a review video for that in case you have not gone over that yet. So now let's just dive straight into this and let's figure out how do we do polynomial operations. So when we're doing addition and subtraction, it's really no different than any other combining of like terms that we've done in the past. If you want to see my video on that also, I have a video on the YouTube channel right now on combining like terms. But we're doing the same exact idea right here with polynomial operations. The only thing that's new here is that we have powers like to the second power, to the third power, and different things like that, which might make it a bit more confusing, but it's really the same exact thing you're doing. So let's dive into number one. So in this case, we are doing addition. So as we can see here, we have 5p squared minus 3 in parentheses plus another parentheses, which has 2p squared minus 3p cubed. So how do I solve this? So since there's a plus sign right here, we could just pretty much add everything up together. And we don't have to worry about distributing or anything like that, which we'll see in the next problem, which we will have to do. But for this one, we can just combine the like terms right now. So we take our 5p squared, and we take our 2p squared, because these are like terms, so we could add those up together. Then we have our next term right here. We have negative 3, so I'll do minus 3. And then we have another term right here, completely different, negative 3p cubed. So we'll put a negative 3p cubed. So again, we could only combine like terms in this case. So let's just combine the like terms. So we have 5p squared plus 2p squared, which is 7p squared. 7p squared minus 3. There's nothing else we can combine with that minus 3, so we'll just leave that alone. And then minus 3p cubed, which we'll also leave alone. And there is our answer. So all we're doing here is really just combining like terms. Not that big a deal. Let's look at this one. This one may throw some of you off. What we have to do when we see anything like this, where we have a negative sign right here, is we distribute the negative sign to everything in our parentheses. Because if you think about it, it's like a negative 1 right here. So we have to multiply the negative times everything inside the parentheses. And then we could solve. So this would become a cubed minus 2a squared minus, and then minus would multiply times this, which is going to become minus 3a squared, and then distribute this, plus 4a cubed, because we distributed that negative. So now that I've done that, now at this point, I could just do it like I was normally doing it in this last problem right over here. So we're going to do the same exact idea. We're just going to combine every like term that we possibly could. So we have an a cubed right here, and we have a 4a cubed over here. So we could add these up together. Then we have a negative 2a squared, and we have a negative 3a squared. Then we could add these and simplify these, so this becomes 5a cubed, and then we have a negative 5a cubed. Sorry, negative 5a squared. So as we can see here, and I think you guys hopefully have by now noticed the pattern between what I was just doing. when we are adding and subtracting, we leave these exponents alone. We leave the exponents alone, but the coefficients in front of the variables are what we're changing, and we are adding and subtracting those. We're not actually changing anything with our exponents, right? Everything's going to stay the same. We're only caring about these coefficients, and that's what we're adding. That's what the operations are happening with. It's not happening with these exponents, and that usually throws off a lot of kids. I know when I was first learning this, I was confused too, because I thought we having to add and subtract the exponents. But if you know your exponent rules by now, you know that if we're adding the exponents and the two things have the same exponent, we leave that alone when we're adding or subtracting. So hopefully that wasn't too bad for you. Just remember you're adding or subtracting coefficients. So now that I know this, let's go on to something called multiplication of polynomials. So this is a bit different. So now, unlike addition and subtracting, multiplication it would actually affect both the coefficients and the exponents. And again, if you know your exponent rules, you should know this pretty well. So let's do some examples. So let's see if you remember, and if you can apply the skills we've learned from every single video I've done so far into this. So 6v would have to be multiplied and distributed to everything on the inside, right? So we would begin 6v times 2v, which is going to be 12v squared. The exponent rule is that when you're multiplying something like this, you'd have this is to the power of 1, and this is to the power of 1, so it would become v squared. So again, know your exponent rules. I keep saying this, I'm a broken record, but yes, you really need to know your exponent rules for this video. Then we have to distribute the 6v to 3 to the 3, so we'd be adding 18v. Okay, so that is all we do, and that's how we get our answer. Not too bad at all, but if you just need to know those rules, and you know pretty quickly how to do these. So now this new one, this is going to be an interesting one, because now I'm going to be teaching you guys about something called FOIL. And FOIL is what we do when we're trying to multiply two polynomials, like in this case, and we can't just distribute like in this problem up here. So what am I going to do? So FOIL stands for first, outer, inner, and last. So FOIL. That's FOIL. So now what does that mean? So let's see. Okay, so when I have these like two things together, I want to figure out so how can I actually multiply both of these in such a way so I could make sure everything is getting multiplied. So the first step would be to do the first terms of both of the parentheses. So the first term is this. This is the first term, and this is the first term of each parentheses. So we'd multiply the 2n times a 6n. So 2n, here I'm gonna lay it out like this, and we can see each step like this. FOIL. So FOIL. So let's begin with FOIL. The first step is 2n times 6n, because those are the first terms we have. So 2n times 6n. We'd multiply those two things together, and then when we multiply that with our exponent rules, we know that becomes 12n squared. The next thing to do is our outer. So what are our outer terms now? So let's go back. Our outer terms means the things on the outsides of both parentheses and overall. So this is the first outer term always, and this is the next outer term always. So we look at these two terms. So we're multiplying the 2n times the 1. And then that would become 2n. Now we look at our inner terms. So our inner terms are going to be the two terms that are inside. So it's always these two terms. And just to make clear, what these things I'm showing you, what the first term looks like, what the outer terms look like, what the inner terms look like, those are all going to be the same every single time you do these problems. So the inner terms, again, are 2 and 6n. So we'd multiply the 2 times 6n. That becomes 12n. And then finally, we have our last terms, which are the 2 and the 1, right? So again, this is going to be the same every single time you do a problem. So 2 times 1. So that becomes 2. Now that I know that, we just add all of these things I just solved for up. So it becomes 12n squared plus 2n plus 12n plus 2. So that simplifies to 12n squared plus 14n plus 2. And that is our answer right there. Pretty perfect. So again, FOIL is a thing you need to learn about. This is the lesson where you learn about it. So again, first, outer, inner, last. And this only happens for multiplication. And you have with two groups of parentheses. And each group should have two terms in them each. So we have 2n plus 2, for example, and we had 6n plus 1. So those are two terms in each of the parentheses that we had. So that's the perfect way to use FOIL. So now that I know how to do that, I want you guys to try these two problems. This should be pretty simple. The first one is just subtraction. So remember, you do not do FOIL for that one. You're just going to do normal subtraction like I taught you. Combine the like terms. Make sure to distribute this to both of the terms inside there. That's my little hint for you guys. And then for number 2, right here, I want you guys to do FOIL. So again, because there's two terms in here and there's two terms in here, I want you guys to actually try to figure out how to multiply both of these things. So pause the video, try both of them, and then come back and I will go over them and you can see if you got it right. Okay, so now we're going to try to combine like terms. So let's begin with this one. We have 3x to the fourth minus 3x and then minus 3x again plus 3x to the fourth. And the reason where did I get this from, you're asking? It's because I distributed this like I just said. You distributed this, so it becomes negative 3x plus 3x to the fourth. And then at this point, now what we're going to do is we're going to simplify this. So we're going to combine the like terms. So we get 3x to the fourth plus 3x to the fourth minus 3x minus 3x, which simplifies to 6x to the fourth minus 6x. And that is our answer. Our next one, we do FOIL, as I just said, because there are two parentheses, parentheses 1, parentheses 2. And on the insides of them, we have two terms each, right? So now that I know this, I'm going to do FOIL. So remember that FOIL stands for first, outer, inner, and last. Okay, so how do I do this now? So let's look at our first terms. Our first terms are always this term and this term. That's just always how it is. So it would be 3m for first, outer, inner, last. So yes, for your FOIL, you'd have your 3m times your 8m, because those are the first terms of each parentheses, which becomes 24m squared. Then we have our outer terms, which are 3m and 7. So we multiply 3m times 7, and that becomes 21m. Then we have our inner terms, which are negative 1 and 8m. So we multiply those. That's negative 8m. And then finally, we have our last terms, which are negative 1 and 7. So negative 1 times 7. It becomes negative 7. And now we take all these things I just solved for, and we will add them up together and simplify it. So this becomes 24m squared plus 21m minus 8m minus 7. So now we simplify that to 24m squared plus 21m minus 8m, which is 13m minus 7. And that is our answer. That is all you do. So again, this is not too bad, but you have to know the rules. So if you struggle at all with this video, watch out for my next exponents video, where I will do a review on exponent rules. And you should also check out my videos on combining like terms. So if you could do these two things and then review the lessons of FOIL from this video and make sure you know how to do addition and subtraction, then you should be good to go. All right, thank you so much for watching. Check out the next video. Thank you.